implicit differentiation and try a few more examples. So for this one I have x cubed plus y cubed equals 18xy. So of course first thing we have to do is use our product rule on the 18xy. So f is 18x and g equals y. So f prime is 18 and g prime is 1 times dy dx, or just dy dx. So my derivative of this function is 3x squared plus 3y squared dy dx equals 18y plus 18x dy dx. Then getting the terms with dy dx on one side, 3y squared dy dx minus 18x dy dx equals 18y minus 3x squared. Factoring out the dy dx gives me dy dx times 3y squared minus 18x equals 18y minus 3x squared. So the derivative of this, dy dx, equals 18y minus 3x squared all over 3y squared minus 18x. All right, let's look at another one where we're going to have to use the chain rule. So I have 3xy plus 7 quantity squared equals 6y. So the very first thing we need to do is that inside function. This inside function is u, 3xy plus 7. So in order to do the derivative of u, I have to use my product rule. So f equals 3x, g equals y, f prime equals 3, and g prime equals dy dx. So I have u squared equals 6y. So the derivative of this is 2u times u prime equals 6 dy dx. Then plugging in my u and u prime, I have 2 times 3xy plus 7 times my derivative of u, which I didn't finish putting up here, but we'll do it right here. So f prime times g, 3y plus 3x dy dx equals 6 dy dx. Then of course we're going to have to simplify it by foiling this out. So I have 2 times 9xy squared plus 9x squared y dy dx plus 21y plus 21x dy dx equals 6 dy dx. Close my parentheses here, which should go right there. Then we do have to simplify and multiply everything by 2. So I have 18xy squared plus 18x squared y dy dx plus 21y plus 21x dy dx. Hang on, I didn't multiply those last two terms by 2. It's be 42 and 42 here equals 6 dy dx. And moving everything with dy dx gives me 18xy squared plus 42y equals 6 dy dx minus 18x squared y dy dx minus 42x dy dx. Factoring out the dy dx gives me 18x y squared plus 42 y equals dy dx times 6 minus 18x squared y minus 42x. And then, of course, the last step we'll have to divide by the 6 minus 18x squared y minus. So then dy dx equals 18x y squared plus 42 y all over 6 minus 18x squared y minus 42x. Okay, let's try one more, and we'll do one more finding the tangent of a line. So I have x squared plus xy minus y squared equals 1. So in this center piece here, I do have that product rule. So my f is x and my g is y. My f prime is 1 and my g prime is 1 dy dx or just dy dx. So my derivative of this is 2x plus y plus x times dy dx minus 2y dy dx equals 0. And again, getting dy dx by itself, I have x dy dx minus 2y dy dx equals negative 2x minus y. Factoring out dy dx, then dividing by the x minus 2y, so dy dx negative 2x minus y all over x minus 2y And then we want the equation of the line tangent to the curve. X squared plus xy minus y squared equals 1. But we do want to find it at the point 2, 3. So everywhere I see x, I'm going to plug in 2. Everywhere I see y, I'm going to plug in 3. So I have negative 2 times 2 minus 3 all over 2 minus 2 times 3. It's going to be negative 7 all over negative 4, or 7/4. So that's our slope for this tangent line. Now we need to write that equation. So my slope is 7/4. My point is 2, 3. Again, we're going to use the y equals mx plus b. So I have 3 equals 7/4 times 2 plus b. 3 equals 7/2 plus b. So b equals 3 minus 7/2. So b equals negative 1/2. So my equation of the line tangent to that curve at the point 2, 3 is y equals 7/4 x minus 1/2. Okay, well, we will see you next time. Thanks.